Hello, this is Abishai Elizondo, and this is molarity, how to compute it when a solution is diluted. So first things first, let's go over the definition of what exactly molarity is. Molarity is a unit of concentration used to describe how much of a substance is dissolved in a solution. It is denoted by a capital M and is measured as moles of solutes over liters of solution. Now we're going to go over a very brief history of molarity and its applications. So the term molarity was first recorded to be used in the early 1930s. The origin of the term derives from the word mole, which was coined by a German scientist by the name of Wilhelm Ostwald from the German word for molecule. Fast forward to modern day, molarity is now used in various laboratories to calculate exact measurements to obtain specific concentrations in order to synthesize compounds such as salicylic acid, commonly known as aspirin, and pesticides. So now that we've gained a little bit of background information on the topic of molarity, now we're going to explore how to solve for molarity, and we have an example problem here. But before we do that, let's remind ourselves that molarity is calculated by dividing the moles of solute by the liters of solution. So in our example problem, we have here a 452 milliliter sample of tea which contains 0.122 moles of sucrose, also known as table sugar. What is the molarity of sucrose in the sample of tea? So it's a fairly easy breakdown. It's really a two-step problem. So for step one, we would convert the milliliters to liters because molarity is measured in moles over liters, right? So there's 1,000 milliliters in 1 liter. So we would take 452 milliliters, divide that by 1,000 to get 0.452 liters. Now in step two, we would solve by dividing moles of solute by liters of solution. So we take the 0.122 moles, divide that by the 0.425 liters that we converted to, and that gives us our answer that we're looking for, which is a molarity of 0.267. Now leading into a slightly more advanced chemistry concept, we're going to now learn how to solve for molarity when a solution is diluted. Now dilution of a solution involves adding more solvent to a solution that has already been created, thus decreasing the concentration of the solute and increasing the total overall volume. Now the equation that we're going to be using for this type of calculation is M1 times L1 is equal to M2 times L2, where M1 and L1 refer to the concentration and volume before the solution is diluted. So this is usually what's given to you, which is in terms of the original concentration and the original volume of the solution. And we have M2 and L2, which respectively refer to the concentration and volume after the solution has been diluted. So having learned the theory of how to solve for molarity when a solution is diluted, we're now going to exercise that with an example problem. If 1.5 liters of a 6.0 molar solution of sodium bicarbonate is diluted to a volume of 4.0 liters by the addition of water, what is the resulting molarity of the newly diluted solution? Now in step one, what we're going to do is set up our equation. Of course, we know that equation to be M1 times L1 is equal to M2 times L2. So we will get our given values and plug them in. And now we have 6.0 molar concentration times 1.5 liters is equal to M2, which is what we're trying to solve for. That's our unknown, times 4.0 liters. Now in step two, now that we have our equation set up, what we need to do with that equation is rearrange it algebraically so that we can solve for the molarity of the newly diluted solution. When we do that, we now have M2 is equal to 6.0 molar concentration times 1.5 liters divided by 4.0 liters. Heading into step three, now we are actively solving for molarity. So we would just take that 6.0 times 1.5 and get 9.0 and divide that by 4.0 liters, to which we would get our answer, which is the molarity of the diluted solution is 2.25. And that is how you solve for molarity when a solution is diluted. These are the sources utilized to present the information in the video. This is Abishai Elizondo. Thank you for your time.